Tonight, if the sky is clear, you will probably glance up at the moon without thinking twice. It looks the same as it did last night. It looks the same as it did in your grandparents' oldest photographs. But the real answer is far stranger. The moon is leaving you. Right now, it is drifting away from Earth at about 3.5 centimeters a year. That sounds too small to matter. It is not. Your ancestors never noticed. How could they? A few centimeters a year is invisible across one lifetime. But stretch that drift across hundreds of millions of years, and something enormous emerges. The moon you see tonight is not the moon your species has always seen. It used to be closer. Much closer. How does anyone even know this? In 1969, Apollo astronauts left mirrored panels on the lunar surface. Scientists, including physicist James Fowler, began bouncing lasers off them and timing the return. Decade after decade, the pattern held. The moon was creeping outward. Why would a giant rock in the sky slowly crawl away? The answer is tides. Your oceans bulge toward the moon, but Earth spins faster than the moon orbits, dragging that bulge slightly ahead. The bulge tugs the moon forward, and anything sped up in orbit climbs higher. Energy that once spun the Earth is quietly being handed over to push the moon farther out. That trade has a hidden victim. Your days are getting longer, barely today. But rewind far enough and the numbers stop being small. In 1963, paleontologist John Wells studied fossilized coral from 400 million years ago. It showed roughly 400 growth bands per year, not 365. The year was the same length. The days were shorter. Back then, a day lasted closer to 22 hours. Sound impossible? The fossils disagreed. Go back further to the moon's birth, and the picture turns unrecognizable. Most scientists now support the giant impact hypothesis, modeled in 1975 by William Hartmann and Donald Davis. A Mars-sized object struck the young Earth. Debris flew into orbit and clumped into the moon, sitting perhaps 10 times closer than it does now. Picture that moon. Not a pale circle, but something dominating the entire horizon. Tides would not lap gently at a shore. They would surge violently, reshaping coastlines in a single day. Earth would spin so fast, a full day may have lasted only 5 or 6 hours. Why should any of this matter to you now, scrolling through an ordinary week? Because astrophysicist Neil Cummins modeled what Earth would look like without a moon, and the results were unsettling. Without its steadying pull, Earth's tilt would wobble chaotically, swinging between mild seasons and brutal extremes. That stability may be part of why complex life had the calm conditions needed to evolve at all. Here is the part that tends to catch people off guard. This will not stop. Hundreds of millions of years from now, the moon will drift far enough that it can no longer fully block the sun. Total solar eclipses will simply stop happening. Every eclipse humanity has ever witnessed is a temporary coincidence of timing, a brief window where the moon's size in the sky happens to match the sun's. Does that make your worries feel small? It should, in the best way. The moon drifting a little farther this year will not trend anywhere. But it is a quiet reminder that the sky above you is not fixed scenery. It is a slow-motion event, unfolding across a timescale so vast. Your entire life is a single blink inside it. So tonight, when the moon looks exactly as it always has, remember that appearance is lying to you a little. It has never been still. It has been retreating since the day it was born, dragging your days longer, one invisible increment at a time. The moon is not simply hanging there above you. It is leaving, has always been leaving, and will keep leaving long after there is no one left to notice.